Well, hello YouTube, it's me, Fortmaster, and welcome back to a Kurzgesagt reaction. And thinking about it, it's been a while since I've done a reaction to one of these. And also a while since I've actually watched anything from Kurzgesagt. I don't know why, I just kind of fell off from watching them. I can't think of a particular reason why. But I saw this in my, notifications feed, and well, I mean, let's just say that I was very curious. This is the Blackholes' evil twin, Gravastars Explained. So I was kind of curious about this video, mainly because it reminded me, at least from the title, of like the very first Kurzgesagt video I ever did a reaction to, which was about black hole stars. And actually thinking about it, I just gotta check something. Yeah, and that was actually all the way back in 2002, back in December as well. So it's almost been 2 years at the time of recording since I started doing Kurzgesagt reactions. So, hey, what do you know? But I mean, just that, a star that is quite literally so astronomically large that it forms a black hole in its center before it even dies out, that was nuts. And the fact we potentially have something else, and I'm aware, the black hole star is purely theory at this point, because even in the video they talked about how it would have only been possible near like the beginning of the universe. But here we have something else, a Gravastar, whatever that is, seemingly being a black hole's evil twin, which, I mean, usually the black hole is considered the evil twin of a star. So, I mean, calling a Gravastar the evil twin of a black hole, would that mean that it's good, or that it's even more evil than a black hole? I am very concerned, but also equal parts fascinated and very curious. Yeah, I really want to see what this is going to be about. So, yeah, of course, as always, original videos linked in the description if you haven't seen it for some reason. Corner video will lead to my Let's Play of the day. And yeah, with all that out of the way, let's get this thing started then, shall we?
There might be an object so indestructible, extreme and brutal that it could kill black holes. Gravastars. Cosmic soap bubbles filled with pure energy and with a shell made of the weirdest material that's possible in nature.
Wait, so is this even weirder than strange matter? Because I remember there being an old Kurzgesagt video about strange matter. And wait, so this could indestructible. So this would be even more than oh god, what was it called? They were like black dwarfs or something like that, stars that were only held together by like the negativity, the negative charge of electrons, and then they fuse together and it would into like iron or something like that. God, the universes could potentially be so weird.
What are they? What do they look like? And are they just a theoretical fever dream, or will they change our understanding of the universe forever? The birth of the most extreme objects in the universe.
Again, Gravastars. Like, are they actual stars? But if they can destroy a black hole, are they made of, like, negative matter? What is this?
Very massive stars die in the most dramatic way possible.
Yes, heard this all before.
We've explained this process in detail before. But in a nutshell, in less than a second, their cores collapse, crushed under their extreme gravity. The star's shell rushes in, bounces against the collapsing core, and explodes, shining brighter than whole galaxies. Depending on how massive the star was, there are two possible outcomes. Either
neutron
the core
star
compresses
or black
into
hole,
a super-dense neutron star, or it kind of breaks reality and collapses into a singularity, an infinitely dense point with no size or dimensions at all. A place where the laws of the universe stop making sense and time and space are reversed. A black hole. Gravastars are a third, even weirder option.
Okay. I guess that answers the whole question of where they come from. But, God, what?
Instead of collapsing into an infinitely dense point, the core is kind of ground down, like a rock pulverized to dust by a cosmic hydraulic press. atoms and particles are crushed so hard that they transform into pure energy. A sort of mini-universe, if you want. And just like our universe, this bubble violently wants to expand and grow. In a fraction of a second, the bubble smashes into the collapsing star around it. The unspeakable mass of the star collapsing under its own gravity meets the titanic violence of the expanding energy bubble. Like an ancient god hammering on its anvil, matter is trapped between an immovable object and an unstoppable force, forging a new kind of material that we've never seen before, but that we know is physically possible. And then it suddenly stops. A Gravastar is born. What does it look like? Cosmic soap bubbles.
Okay, cosmic soap bubbles. So, okay, so again, it's the whole thing of, you know, gravity, the gravity of the star sucking things in, and, you know, the energy inside wanting to expand, kind of balancing out. But in this case, it's like you don't have one overpowering the other. God, this is weird. But okay, so yeah, so if I remember from, you know, all the science videos that I've watched over the years, you know, energy can't be created. It can only change forms. So that includes going into matter. So if you have this, you know, cosmic anvil, so to speak, transferring all the matter inside of it into just energy, like no matter what kind of energy that is. Oh, is that where the cosmic soap bubble thing comes in? Because like it's not. So like potentially you could have like the energy inside. Wait, but does pure energy have gravity though? Because the whole thing, this all hinges on like the gravity of the star itself, keeping it compressed from the energy expanding. Okay, this whole thing's starting to hurt my head.
Just like black holes, a Gravastar can have any mass, but a typical one would be about the size of the London metropolitan area and as massive as 10 suns. The shell of the Gravastar is utterly dark and the coldest thing in the universe, only a billionth of a degree above absolute zero. If we look at it in deep infrared, even the cosmic microwave background glows bright in comparison. How can anything made of matter be that cold? Don't all atoms jiggle back and forth? The thing is, the shell's not made out of atoms. It's made from an entirely new, unique and extreme matter that doesn't have a name yet, and that's at the very limit of what's physically possible in nature.
Galactic flubber!
Actually, the shell is so incredibly thin that atoms seem truly gigantic next to it. And yet, despite being ultra-thin, because it's been forged by two impossibly extreme forces, the shell is incredibly tight. So tight that if you wanted to stretch the whole shell by just 1 meter, you'd need the energy of an entire supernova. What about the inside? Well, it only gets weirder. The interior of a Gravastar is perfectly simple because it's sort of empty. Completely empty. A perfect vacuum without a single atom, particle, or wave. But despite being as empty as it gets, this vacuum is boiling with the most primitive and fundamental kind of energy in the universe. We need a detour to explain how any of this makes sense.
Okay, so I was right, but I didn't even think about the whole... If you transformed all of the matter inside into pure energy, you get a perfect vacuum. Because, like, again, not even space is a perfect vacuum. I think I remember hearing from something years ago that on average you'll find like just deep space is like you'll have like maybe like 1 to 8 atoms of hydrogen every square meter or something. But a perfect vacuum with absolutely nothing. Jeez, how the fact that the inside of this thing, you know, again, if it even is physically possible and real, is even that again, the inside of an object is emptier than deep space. Again, going to the whole analogy of it being a cosmic soap bubble, it's not gravity holding it together. It's this weird, again, whatever, they haven't even described what this matter is, this weird super material that's so thin that not even describing it in atoms is possible.
The fundamental nothingness at the core of it all. The inside of a Gravastar breaks our brains a bit because it's a sort of super-condensed nothingness. What does this even mean? We'll have to simplify and use metaphors to make sense of what scientists measure and calculate.
You know, you gotta love the fact that seemingly, again, like they describe it as a black hole's evil twin. You know, a black hole breaks our brains a bit. But even this, like, this is just more brain-breaky.
According to our current understanding of physics, particles like quarks, electrons, photons, and so on are not really solid objects, but sort of waves in an ocean. In our human world, you can't have waves without water, and in the smallest world, you also can't have particle waves without some kind of underlying, omnipresent cosmic fluid. This fluid is the vacuum, what we perceive as nothingness. It's the fundamental ocean at the bottom of reality. The waves of this vacuum ocean are the particles that make up you and everything else. But even when there are no waves or particles traveling through it, the fluid is still there, and like any fluid we know, it has inherent energy. Vacuum fluid is everywhere in the universe. The room you're in is 99.98% vacuum between the air particles bouncing around.
Yeah, I remember that.
Between the trillions of particles making up your cells, there's vacuum. But it's different inside a Gravastar. When our star collapsed and condensed so violently, it was as if the universe took a cosmic pump and compressed as much vacuum fluid as physics allows, into a kind of super dense nothingness. As said before, even without any waves, the nothingness vacuum ocean of the universe has energy.
That is such an oxymoron of a sentence. Super dense nothingness. That is a sentence, all right. And thinking about it, I am starting to see how this, you know, could be classified as the evil twin of a black hole, where in a black hole you have matter and, you know, potentially everything, like, in an infinitesimally small point. And yet with this, you have near infinite nothingness. So when you have absolute nothingness crash into something that is like infinitesimally dense everythingness, yeah, it just annihilates, because you just kind of get you just kind of spread out the difference there, and then and you're left with nothing, with a regular nothing, not super nothing.
But the super dense vacuum inside a Gravastar has almost a billion, trillion times more energy per cubic centimeter than the vacuum outside the star. This is an unbelievable amount of energy and mass in a tiny space, just like, you may have guessed it,
a black hole.
This intensely compressed vacuum ocean can't be compressed any further. It's at the absolute physical limit of anything that can be squeezed together without breaking physics, like black holes do. The ocean would love to stop being so tight. It wants to stretch out and flow back into the ocean that surrounds the star, but it's trapped in the safest prison possible. The shell, which itself is right at the edge of the physical limit of any material possible.
And what's the shell?
An eternal stalemate between two limits of the universe. Let's leave this world of metaphors and get back to our world that feels more real. In our world, Gravastars are perfectly black, eternal objects with borderline insane amounts of mass. Because they're so cold, dark, and massive, from the outside, Gravastars look and behave exactly like black holes. Both massively curve space around them and create all the fun effects we love black holes for, from trapping mass and light in accretion disks or slowing down time as you get closer. For details, we've made 1 or 2 videos on black holes before.
Oh god, now I'm getting ideas for potential sci-fi settings where you have a galaxy that's not orbiting a supermassive black hole, it's orbiting a Gravastar. And I mean, granted, I don't know what that would do, like, to the setting itself, but god, that would be weird.
If you fell into a Gravastar, you'd be extremely dead before you even hit the surface.
Not even spaghettified.
And ground down by the gravitational forces. And once your scattered remains touch the shell, the atoms you were once made of would probably break down and dissolve completely, only to be converted into the vacuum energy of the interior, making the Gravastar an infinitesimal bit bigger and an infinitesimal bit more massive. Okay, this was fun and all, but what exactly is the point? Isn't this just another video of wild scientific speculation just for the sake of it?
Yeah, kind of is. I mean, if you think about it, a lot of their videos are like that, but it still doesn't change the fact that it's cool, just, you know, in the whole, like, potential theory of the whole thing.
The point. Black holes were suggested more than a century ago as an abstract solution to equations of gravity. For more than 50 years, they were considered mathematically valid, but too absurd to be real. Few believed they actually existed. But scientists kept working on paper and looking at weird things, and then we saw stars being thrown around by invisible titans. We saw light stretching around invisible gaps in the sky, and as our technology and theories improved, we even sort of took a picture of them. We have evidence for them, and they fit our theories, and nowadays it's kind of common sense to accept them as real. Black holes are extremely elegant and fascinating, but they also created a lot of questions that have traumatized physicists for decades.
Traumatized, yeah, that's the right word for it.
Singularities literally break our best understanding of physics. They seem to delete information, which shouldn't be possible. Gravastars are a relatively new idea without any of those problems. They don't need singularities that break physics or delete information. They solve the puzzles of black holes, but they too create new problems, like weird exotic matter for their incredibly cold and tight shell,
Galactic flubber,
super dense nothing to make a supermassive empty core. But just like black holes, they do...
Again, I can't get over the fact that these things are filled with super dense nothingness. I mean, that sounds like the most sci-fi concept and imaginable. It's not just nothing, it's super dense nothing. That's almost like schoolyard level, like Infinity+1 shenanigans going on there.
Do work on paper and fit what we see in the sky. So, are they real, and will we ever know? Actually, there is a way to find out. Black holes have an event horizon, while gravastars have a physical shell made of matter, which means that they behave very differently when they smash into each other. The collision of two objects as massive as they are creates huge amounts of gravitational waves, ripples in space-time that travel at the speed of light.
But I would imagine it's different enough from, say, two black holes smashing into one another that you'd be able to tell the difference.
You can think of them as the music of cosmic cataclysms. The collision of two black holes should sound like a bass drum, a deep thump that stops quickly. But two gravastars colliding should sound like a gong, leaving subtle echoes behind. Scientists are listening for these echoes in the music of the cosmos. Unfortunately, black holes and gravastars are surrounded by such strong gravity that it swamps most of the music. It's like trying to tell two instruments apart through a thick wall of concrete. You need very sharp technology for that. While we've made incredible progress in the last few years, we're not quite there yet. So this is where we'll end this story. Gravastars have the potential to answer some of the biggest problems in physics. Or they're just another idea for our discard pile. But this is why we do science. To learn that everything is different to the way we thought it is, until the day we truly understand the nature of reality.
Oh god, this whole thing. I also kind of remember, it kind of reminds me of that one episode from SpongeBob where he was at rock bottom. And it's like,
this isn't your average everyday darkness. This is advanced darkness.
But instead of, you know, darkness, this is advanced nothingness. You didn't think it was possible to get emptier than empty, but here we are. We have a potential, like a potential object in the same realm as black holes that instead of being super dense things of everything are super dense nothing. It's so weird. Actually, that's almost an idea thinking. Like, we always come up with questions as like, what is, you know, how did the universe come to be? What caused the Big Bang? You almost wonder, what if it wasn't like a supermassive black hole blowing up and releasing everything that was in it or something? What if it was almost like a gravastar? Because they said that like the energy inside is like, it was almost akin, it's like, I forget how they even described it. Well, what if it was one of these essentially giant galactic soap bubbles popping and releasing everything that was inside? Again, such a weird concept. And I loved every second of it. Man, because it has been a long time since I watched a Kurzgesagt video. Ah, I've forgotten how much I loved these. Oh, God, yeah, so that's definitely going to be it for now. So, yeah, of course, as always, original videos linked in the description if you haven't seen it for some reason. Corner video will lead to my Let's Play of the day. And, yeah, with all that out of the way, I hope you guys liked. If you did, leave a like, subscribe if not, and I'll see you guys next time. Goodbye.